Let me show you the advantage of knowing how to use sum and difference identities. It's actually quite splendid. Take a look at this first example. It says, I want to figure out 165 degrees. Now, the cosine of 165 degrees, of course, I could just throw it in my calculator and get a wonderful decimal, right? Decimals suck, especially when the question says, give me the exact value. What do? Well, I got it written down right here. Think of composing this given angle as two angles, and especially ones that appear on the unit circle. Oh, I wonder, wait a second. You know the unit circle goes by 30 degrees, 60 degrees, multiples of this, right? Keeps on going and going and going. Or 45 degrees, 90 degrees, and so on and so on and so on. Take a look at this, 165 degrees. 165 degrees in terms of some of these perfect multiples, right, is actually, think about it, isn't that 120 degrees and 45 degrees? Doesn't that give you 165? Of course it does. So you're actually going to use a sum of cosine identity. See, it says right here, use the sum and difference identities and determine the exact value based on the exact values that make this guy up. Oh, I see. Look at this. Check this out. So you're going to use this cosine 1. So wherever you see an A now, that's going to be 120 degrees. So I'm going to put in 120. And it's going to look a little ugly here, but that's okay. Wherever I see a B now, I'm going to put in 45. So there's 45, there's 45. Okay, you can barely see that, but you can make it out, no problem. So this works out to be cos 120, just follow the identity now. Cos of 120 degrees times cos of 45, just like the identity says, it is subtraction. Even though this is addition, it is a subtraction right here. That's what the identity tells us to do. And then we go sine 120 degrees, sine 45. Isn't that nice? Isn't that pretty? Now, let's figure out. Do you remember where a cos of 120 is? Yeah, neither do I. So let's go out and put it in there. Cos of 120, remember, there's 180, there's our 90 degrees. 120 is this guy right here, which is the thin guy, remember? Okay, so there's 120 degrees, which you know is 1/2 root 3 over 2. And it's minus a half actually to get there. All right, so cos of 120 is then minus a half. Cos 45, we don't know yet. Well, we may know in the back of our minds, but let's just say we don't right now. Okay, sine of 120. Oh, that's that root 3 over 2 stuff. Okay, so that's root 3 over 2. And I'm going to multiply it by the sine of 45. Now, we don't know what that is yet, or do we? Yeah, we do. We know it comes to the square one, right? That's the pi over 4 of 45 degrees, right? That's going to be the root 2 over 2, root 2 over 2, 1. So exact value of cos 45 then is root 2 over 2. The exact value of sine 45 is root 2 over 2, and just straight out multiply these guys. Look at this. That's going to give you negative root 2 over 4, straight out multiply, subtract, okay, that's going to give you root 3 times root 2 is root 6. 2 times 2 is 4. Beautiful. Now, put them together. Put them together. Why? The common denominators. This gives you minus root 2 minus root 6 all over 4. And that's your exact value. No decimals, just really, really nice looking roots. Okay, stay tuned. I got 2 more for you coming right up.